In this chapter, we're going to talk a little bit about velocity some more. Now, we talked about speed and the difference between speed and velocity. I'm going to be a little sloppy here. I'm going to say that speed and velocity, we're going to say, is about the same thing, and we're not going to be changing direction. So let's say you're on a road, say Route 80, and let's say you're going through a very flat, straight area of Route 80, say somewhere out in Iowa or Nebraska where it's really flat. And you want to know how far you travel in a certain amount of time. Okay, well, let me see. Let me get a pen out here for a second. So let's say you have the speed or velocity is distance over time. And let's say you know that your speed is about 60 miles an hour, or better yet, 65 miles an hour. And you've been traveling for 3 hours, so you know what your time is. You want to know how far you go. Okay, so what you want to do is solve for d. So you multiply both sides by t. Sorry about being so sloppy here. I'm trying to write with my finger. Multiply both sides by t, and the t's go away on this side. So you have t times v is equal to the distance. Okay, so 3 hours times, what did I say, 65 miles per hour? Or did I say 60? It doesn't matter. Let's say it's 65. And so the hours go away, and you have 3 times 65 is 195 miles. Okay? So that's great. Except what this assumes is that you're going at a steady speed of 65 miles per hour. So basically you're on cruise control for 3 full hours, and you haven't been able to slow down or speed up. You haven't sped up to pass any cars or trucks. You haven't slowed down to take a rest stop or to avoid a car crash. Who knows? But there's plenty of reasons for speeding up and slowing down. So how do you find the distance, or at least your change in position, if there's not a constant velocity or a constant speed? Well, that's what we're going to deal with today. Okay? What you really need to do is find the average velocity. The average velocity is the change in position divided by the time it took for that position to change. Okay? So V average, and in this case we are talking about velocity with a direction, is the change in position, okay, which is represented by S in this particular equation. This is actually something we call displacement, but we'll get to that in a few moments. The average means it's the average. We're going to talk about what average is in a few moments. Okay. S is used for position. Why? Because there's no P in position. There's no S in position. Actually, there is an S in position, but it's because of the Latin word from which position is derived. And of course, the delta, as you know, represents a change. So it's a change in position. Now, change in position is a little different than distance, which I used in the previous example. Distance is basically how much distance you have covered. How much distance your wheels have rotated around along the ground, whether it's straight or not. Okay, but we're going to get to, again, we'll get to the details of that shortly. Okay, and again, the arrow on top means it's not just the speed, but also the direction of motion, which means it's a vector quantity, not a scalar quantity. Okay, same thing with position. Now, both this relationship and the law and force of motion involve velocity, but one involves the average and one involves the change in velocity. Now, what if the velocity is not constant? In the last chapter, we talked about acceleration, and acceleration by definition is the rate of change of velocity. Can we still determine the change in position if our velocity is not constant, if it changes? And the answer is yes, if you can find the average velocity, okay, which we just talked about on the previous page. So how do we determine the average velocity? Okay. Well, let's talk a little bit about what average is, first of all. An average of a test in a class is not the same, by the way, as the mid-range score in a class. So if I have a class of students I give a test to, and the highest grade is 95, and the lowest grade is 35, would the average be 65? Probably not. There would be cases where it could be, or it could be close to that if it was a very evenly spaced group of numbers. But the mid-range number from the highest to the lowest is not always, in fact, it's usually not. It's usually not the same as the average. Okay, if you have a lot more people scoring above 65, then the average will be higher. If you have more people scoring below 65, the average will be lower. Make sense? Okay. So the average velocity is not the same as the initial velocity. It's not the same as the final velocity. It's usually not the same, or at least it's not always the same as the mid-range velocity, and it certainly isn't the change in velocity. So now I've told you what it isn't. What is it? Okay. So when we talked about an average of class scores, we said we add up all the values and divide by the number of values, right? Well, actually, we didn't say that, but that's hopefully you understand that that's what we do, right? So if you have 25 students in the class who've taken the test, you add up all 25 scores, and then you divide by 25, the number of students who took the test. Okay. The average is always in between the minimum and maximum. I mean, obviously, that really shouldn't even have to be said, because if you have a minimum score, that means there's nothing below it. So why would the average be below the minimum score? And if you have a maximum score, nobody scored higher than that, so why would the average be any higher? So that's something we probably shouldn't have had to say, but just for completeness, we did so. Okay, but as I said, it's also not always halfway in between. Okay. All right, here we have a picture of a car, a little cartoon car, toy car actually, it looks like, going across the floor. And it goes a distance of 10 meters in 5 seconds. Okay. This is also what we call a time-lapse picture, which we're going to be talking about at the very end of the chapter. So we superimpose the pictures showing the object's position at a uniform time. Now, is this car going at a uniform rate? Is the velocity a uniform thing? Well, it goes 10 meters in 5 seconds. So that means the speed, which is the magnitude of the velocity, should be 10 meters divided by 5 seconds, and that should be 2 meters per second. Well, sure enough, you got 2, 4, 6, 8, 10 meters. It seems to be going, this is 2, 4, 6, 8, 10. It seems to be going 2 meters in the first second. It goes another 2 meters the next second, another 2 meters the third second, another 2 meters the fourth second, and another 2 meters the fifth second. So it looks like it's at a constant speed of 2 meters per second. Okay? So in this case, the average is the same as the instantaneous speed. The instantaneous speed is what your speedometer would show you. It's what your speed is at that instant of time. Okay? In this case, the instantaneous speed is the same as the average speed because it's not changing. Okay? But if the velocity is not constant, then you have to determine the average. Well, here's where our talk of acceleration can help you out a little bit. Okay? Because if the velocity is changing uniformly, By uniformly meaning it's speeding down at the same rate, it's speeding down. It's speeding up at the same rate or slowing down at the same rate. The average velocity is the mid-range value between the initial and final. Okay, so in other words, if you had a car that was increasing in speed from 40 miles an hour to 60 miles an hour uniformly without like some kind of a herky-jerky change in the gears, that means that the average velocity would be halfway between 40 and 60. It would be 50 miles an hour for those however many seconds it took to go from 40 to 60. Okay. So when the velocity changes uniformly, that means that the net force is constant. And that's what we call constant acceleration. Okay. Constant acceleration is such a difficult term for a lot of students to get. And I think the reason is the word constant seems to mean like nothing's happening. But acceleration means that something's definitely happening. And in fact, something's definitely changing. Okay, so constant doesn't mean that nothing's happening. Constant velocity means that you're constantly changing your position. Constant acceleration means that you're constantly changing your velocity, your speed, or your direction for that matter. Okay, so just because something's constant doesn't mean that nothing's happening. It means that it means that the thing that is constant is not changing. It is continuing to happen at the same rate. Okay, does that make any sense? It's a little tricky. It's a little bit tricky. So if you're having trouble with that, think about it a little bit more or ask me questions in class about it because it is a little bit of a tough concept. All right. Now, we said that this thing S was position. You can also call it displacement. Okay, the change in position is equal to displacement. Okay, so delta S right there is displacement. Now, if you know the average velocity, you can figure out the displacement. So we actually didn't do this example, but we will in class. Let's say you have a car that's going 20 meters per second east, and after several seconds, it's going 25 meters per second east. If it's increasing its velocity at a constant rate, that means the average is going to be 22.5 meters per second. Okay. So the initial is 20, the final is 25. Okay. Let's say it took 20 seconds to increase its velocity from 20 to 25 meters per second. Okay, 20 seconds. That means it travels on average 22.5 meters every second. Now, actually, at the beginning, it was traveling less than 22.5, and at the end, it was traveling more than 22.5 meters per second. But over those 20 seconds, it averages out to 22.5 meters per second because it's in a constant acceleration, and that's the important thing. Okay. So after 20 seconds, it must have traveled 20 times as far as it did in 1 second. Okay, we said it travels 22.5 meters every single second. That means after 20 seconds, it's going to travel 20 times 22.5, or 450 meters. Okay, makes sense? It travels a lesser distance at the beginning and a greater distance toward the end, but on average, we find the total distance is going to be given by the average velocity, and that's 450 meters. Okay, we're almost out of our 15 minutes, so I will continue with this in the next lecture.